So here's our first example for the problems using trig substitutions. And I have the integral of dx over x squared times the square root of x squared minus 9. Now this is just me. I kind of like to write the dx at the back of the problem. In fact, when I had written it in the top when I wrote the problem, just out of habit, I started to write a second dx at the back. So I just, if it's in the numerator, you can just put it on the side. So I got that. Now I'm looking at this. I have the square root of x squared minus 9. And if you look back at the table of trig substitutions, here it is, x squared minus a squared. A is 3 in this problem because I got 9, which is 3 squared. My substitution for this problem is going to be x equals 3 secant theta. So every x becomes secant theta. So I got the integral of 1 over, now I got x squared, so that's 3 secant theta. I'll put the square on the outside. Under the square root, that's the square root of 3 secant theta squared minus 9. And I need a comment on this dx. This is one of the most common mistakes students make in this problem. They forget you have to address the dx. Well, look, if x is 3 secant theta, what is dx? What's the derivative of 3 secant theta? 3 secant theta tangent theta d theta. You have got to substitute for dx whatever d theta is, or whatever the expression is when you've taken the derivative of x. So dx is 3 secant theta tangent theta d theta. And you could put that over 1 if you like, because I'm thinking, you know what, I got to multiply this stuff. I got to simplify this, everything I have here. The first part here, don't forget the 3 is squared as well as secant, where I had that x squared and I did that substitution. So this is 9 secant squared theta times the square root. Well, this is also 9 secant squared theta. And now that's minus 9. And I might as well go ahead and put that 3 secant theta tangent theta in the top. I'll put the d theta at the back again. Inside the square root, factor a 9 out. And you can start simplifying if you want, reducing a few things, but I'll usually kind of wait through a few steps here. If I factor that 9 out, that's the square root. 9 is still under the square root. Secant squared theta minus 1 d theta. Here I can do, since it's multiplied, I can do the square root of 9. Square root of 9 is 3. So 3 secant theta in the top times tangent theta. 9 secant squared theta in the bottom. I'm taking out square root of 9, that's 3. And under the square root, I have the square root of secant squared theta minus 1 d theta. Here's your identity. Secant squared theta minus 1 equals what? Tangent squared theta. So I'm going to have 3 secant theta tangent theta on the top, 9 secant squared theta. I should have multiplied 9 times 3, but I didn't. Well, we'll deal with it later. Secant squared theta minus 1, that's tangent squared theta. Look, that's the square root of tangent squared theta. And the square root of tangent squared theta is tangent theta. Let's go ahead and reduce this 3 with that 3, and I'll write this as secant theta, tangent theta, over 9 secant squared theta times tangent theta d theta. Reduce the fraction. So I'm going to end up with tangent thetas cancel. The secant theta in the top will cancel with one of those secant thetas in the bottom. I'm going to pull the 1/9 out of there, and I'll get 1/9 times the integral of secant theta d theta. What do you do next? 1 over secant theta equals what? Cosine theta. 1/9 times the integral of cosine theta d theta. See, now I can do that integral. What's the antiderivative of cosine? Sine. 1/9 sine theta plus c. Not finished yet. What do I have to do? I gotta go back to x. Gotta go back to x. So, I had this, x equals 3 secant theta. So now I'm remembering, I can write x over 3 is secant theta. I'm remembering SOHCAHTOA from Trig. I need to draw the triangle for this. Here's my right triangle. Here's theta. Let's see, secant theta is x over 3, so that is opposite over adjacent. I need to get the third side. How can I do that? I'll call this third side B. Pythagorean theorem. 3 squared plus b squared is x squared. So b squared is x squared minus 9. b is the square root of x squared minus 9. I'm going to scratch that b out. I don't want it to clutter that up a bit. All right, so now from the triangle, I can read what sine is. Sine is opposite, so that's the square root of x squared minus 9 over hypotenuse. It should be 1/9, thank you. All right, so that's an easy fix. I was afraid I'd made a mistake, a bigger mistake. That should be 1/9. Let me rewrite this answer. So 1/9 times the square root of x squared minus 9 over x plus c. There's my final answer for that problem.